Ignition sequence start.
Good morning. Welcome to Mission Control Houston. This is the scene inside the International Space Station Flight Control Room at the Johnson Space Center, where a team of specialists is always here, keeping tabs on the systems on the space station and working with the crew members, who are now near the end of another work week on orbit. Expedition 58 Commander Oleg Kononenko and flight engineers Anne McLean and David St. Jacques were busy all through the month of January, working with researchers on a wide variety of scientific experiments, including a cool robotics competition just this past week. But they have also been busy cleaning house lately in preparation for a vehicle departure at the end of next week.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Kayla LaFrance. This week, astronauts on board the station have been taking out the trash. The crew has been busy packing and preparing the Northrop Grumman Cygnus CRS-10 resupply vehicle for its upcoming departure from the station. Cygnus arrived at the station back on November 19th. After the crew unstowed over 7,000 pounds of new supplies, they began to fill the vehicle with trash that has accumulated on the station over the past few months. There's no trash pickup in space, which means that the crew has to stockpile it until a vehicle is ready to depart filled with thousands of pounds of disposable items, ultimately burning up in the atmosphere during re-entry. Be sure to tune into NASA TV on February 8th to watch Cygnus depart live starting at 10:45 a.m. Eastern Standard Time. NASA astronaut Anne McLean teamed up with students on the Earth for a high-flying robotics competition. The Sphere's Zero Robotics Experiment is a competition for high school students that has them write algorithms for free-flying robotic satellites, programming them to accomplish complex tasks in space, such as docking, assembly, and formation flight. The competition provides these students the opportunity to act as programmers and ground controllers, giving them hands-on experience with real research in space. The first flight of NASA's Commercial Crew program is right around the corner. SpaceX successfully conducted what's known as a hot fire test with their Falcon 9 rocket on the launch pad at Kennedy Space Center in Florida. This was an important milestone on the road to Demonstration Mission 1, or DM-1, an unmanned test flight and the first mission of a new spacecraft designed to carry astronauts to the International Space Station. DM-1 is currently targeted for February, so head over to nasa.gov/commercialcrew for the latest updates. Keep sending in your questions using the hashtag #SpaceToGround. We'll see you next week.
While Boeing and SpaceX work to get ready to launch astronauts to space from the USA, getting off the ground is just the beginning. Once those astronauts arrive at the International Space Station, they'll be working on research to improve life on Earth and help us send humans into deep space, farther than ever before.
The International Space Station, one of the nation's great assets for research and discovery, is in low Earth orbit. And the Commercial Crew program will be providing transportation to ISS to support that first step as a gateway to space.
The research that we do in low Earth orbit is very important to develop the systems that we'll need and the capabilities that we'll need to protect our crews for these deep space exploration missions.
So the International Space Station is our orbiting laboratory, and it allows us to do research on life and physical sciences and really understand the impact of living without gravity. Because if we understand how organisms respond to gravity and to a lack of gravity, then we'll be able to think about how humans and other organisms might survive on other planets.
It's really a test bed for how do I go away from Earth for 3 years and go to Mars and get back.
Right now, one of the biggest constraints that we have on station is the available hours for astronauts to be dedicated strictly towards research.
And that's why we're so excited by the Commercial Crew program, because it'll be bringing additional astronauts to the space station, so we're going to have a lot more time to do science.
A lot of the technology we've developed on space station has come back here home to Earth in order to benefit people. For example, the robotics that have been so important in the building and the maintaining of the space station have come down to Earth in the form of robotic surgery.
But then think about that crazy day when instead of just having astronauts that represent NASA interests, you're now able to have private researchers that go up to help and look at research that might enhance life on Earth, or looking at ways to better create drugs or therapies that can improve patient care on the ground. Some would sit there and say that's a wild idea, but that idea is coming closer and closer with every single day.
The International Space Station has several laboratory modules that house one-of-a-kind scientific research which takes advantage of the lack of gravity in space to test hypotheses in ways that can't be done on Earth. In the Destiny Laboratory, crew members use a special piece of equipment for experiments which involve potentially hazardous materials. And in the Kibo module, which you see here, the astronauts are using a newer and bigger version of that glove box to support life sciences research.
Thinking inside the box. Presented by Science at NASA. Most people picture a glove box as the small space on the passenger side of your car. But if you're an astronaut floating 250 miles up, you might picture a large glass enclosure that allows you to conduct experiments that could change how we live both on and off Earth. This is the Microgravity Science Glove Box, or MSG. It was installed in the International Space Station, or ISS, in 2002 to allow small and medium-sized investigations from many disciplines, including biotechnology, combustion science, fluid physics, fundamental physics, and materials science. Many of these experiments can involve fluids, flames, particles, and fumes that you wouldn't want to escape into the space station's enclosed space, where they might make the astronauts sick or damage the station's sensitive computers and electrical systems. Instead, crew members install investigation hardware into the box and seal it shut. Next, they insert their hands into what's known as a glove ring assembly to safely manipulate their experiments or samples. Glove ring assemblies are available in a variety of configurations to accommodate differences in crew members' hand sizes as well as preferences in tactile response. The investigator views his or her work through an acrylic window. There's even the capability to install a high-definition camera system with a real-time video link installed inside the box to allow investigators on Earth to watch experiments being performed. The MSG has proven so popular over the past 16 years that a second glove box is being added to the station. The new model will focus exclusively on life sciences investigations and is known as the Life Sciences Glove Box, or LSG. This fully enclosed facility will allow crew members to perform developmental biology experiments on cells, insects, aquatics, plants, and animals. The LSG is almost twice the size of the original MSG and can accommodate 2 astronaut crew members, sometimes guided in real time by scientists back on Earth to conduct 1 or more experiments simultaneously. Safety was a paramount consideration in its design. As air circulates through the workspace, activated charcoal filters continuously clean it by absorbing chemicals that may be present. In addition, a high-efficiency air filter removes particles and aerosols. This allows the facility to provide 2 levels of containment for handling biohazard level 2 and lower biological materials. So why is it necessary to have a glove box on station devoted to life sciences? J. Michael Cole, the deputy manager of the ISS Projects Office at NASA's Marshall Space Flight Center in Huntsville, Alabama, explains. First, exploration crew members will be in microgravity conditions for an extended period of time, and it's important to note how that will affect their physiology and biology. The addition of LSG will supplement the ability to conduct those types of research experiments aboard the ISS. Second, life science experiments may give us new insights into how we treat diseases here on Earth. For instance, treatments for osteoporosis have benefited from research performed in microgravity. The next time you're asked to think outside the box, you may just want to consider one of the most unique labs ever built and think inside the box instead. For more inside information about what's happening inside the ISS, visit www.nasa.gov/ISS-science. For more on science happening on, around, and beyond our planet, go to science.nasa.gov.
Technology research is one area of concentration of the work being done on the International Space Station. Another is research into how the microgravity environment affects the human body. And then there's science in areas like physics and biology that is taking advantage of the weightless environment. For example, there is an experiment in which a device about the size of a thumb drive, which contains human cells in a 3D matrix, may help scientists learn how those cells respond to stresses, drugs, and genetic changes. The devices are known as tissue chips. The same International Space Station crew members who work on a wide range of science experiments in space have also created a series of videos to help students understand topics in science, technology, engineering, and math. In this installment of the STEMonstration video series, astronaut Drew Feustel discusses a developing technology that will support future spaceships traveling out into the solar systems. It's a water recovery system that recycles crew wastewater for consumption.
Hi, I'm NASA astronaut Drew Feustel. Welcome to the International Space Station. On our station, our water recovery system is vital to our mission and our survival. Want to know why and how we recycle and filter our water? Let's go. We use water recovery and filtration because it is expensive to launch resupply missions, and the weight of the water is a problem as well. Think about the weight of a single bucket of water. Can you imagine the weight of water for a month's supply for 6 people on the International Space Station? What about the water for a year or more when we leave low Earth orbit for deeper space missions? That's a lot of water, and bringing it with us is not very efficient. On station, we recycle wastewater to get fresh drinking water. This recovery and filtration process includes our urine, moisture we exhale, and sweat. along with the water we use to bathe and shave. It works like this. When we use the bathroom, urine is collected and pumped to a distillation assembly. The assembly spins, pulling the urine to its walls. The urine is heated to evaporate water from the waste and then condensed in the outer chamber to form distillate. Next, the water is pumped to a tank where it is joined with the water recovered from cabin air created by crew sweat and respiration. Down the line from there, odors and any other contaminants are removed with heat. Then iodine is added for microbial control. Our water is checked often to ensure it meets water quality requirements. It is also monitored closely for bacteria, pollutants, and proper pH. The pH scale ranges from 0 to 14 and is a tool used by scientists to measure the strength of an acid or base. Our water is required to be in the 6.0 to 8.5 range. The end result of the entire process is clean drinking water that we get to enjoy every day. The recycled water on the space station is sterile. There's no odor or bad taste. You've seen that water recycling is critical for long-duration missions, such as here on the space station, and will be for future trips to the Moon or Mars. Be sure to check out the activity connected to this video so you can learn more about water filtration. Thanks for learning with me, and I'll see you next time.
This demonstration videos are one way the International Space Station crew members try to share their mission with students on Earth. Last summer, during a live event with students at the Challenger Centers, former classroom teacher Ricky Arnold shared a video in which he performed one of the lost lessons that Krista McAuliffe had planned for her flight on Space Shuttle Challenger, which launched 33 years ago this week. Let's have a look.
Hi there, my name is Ricky Arnold and I'm living and working on the International Space Station as a part of Expedition 55. Today we're experimenting with chromatography. Chromatography is a technique for the separation of a mixture into its individual components. Let's go ahead and get started. We have a mixture, this black spot, on a piece of chromatography paper. We want to see what different components of light make up black. So we put in the water onto this end of the chromatography paper to see how the ink separates. Water is a universal solvent and should help separate the spots into colors. What do you think is going to happen? Talk about it with your classmates. All right, now let's see what happens. Go ahead and add some water. Here's the first one. Water is going ahead and creeping up the chromatography paper. You can already start to see not much separation here. Very little on this black one, but you can actually see the reds, greens, and yellows starting to separate and make their way up the chromatography paper. The substances, now in liquid form, travel over the solid, the paper, at different speeds, causing them to separate into the component parts. Now that we know what black ink separates into, let's think about how the water was able to move through the paper. I put a drop of water in just one spot, but as you can see, it moved along the paper on its own. How does it do that? Well, it happens through a process called capillary action. Capillary action is when a liquid like water moves upward due to its cohesive and adhesive properties. In other words, water molecules are able to essentially stick together and stick to one another, which is cohesion. And they can also stick to a surface or a container, in this case the paper, in a process called adhesion, and that adhesion pushes it upwards. This happens in microgravity and on Earth. You could try another experiment with chromatography with your parents or your teacher. Grind up some green leaves into a real fine pulp and use some acetone or nail polish remover instead of the water. Leaves are green because they have a chemical called chlorophyll in them, a chemical that can use sunlight to make sugar and oxygen through a process called photosynthesis. However, there are other chemicals in leaves that do the same job, but we just don't see them until fall when the chlorophyll breaks apart. Another way to see fall colors any time of year is to use chromatography. Well, now that we've done this experiment in microgravity, think about how this might look different on Earth. Will the material setup be the same? Will water behave in the same way? Will the same separations happen? Discuss it with a friend, then give it a try. Thanks for participating in our experiment today. I'm Ricky Arnold. We'll see you next time.
NASA astronaut Anne McClain is in the 61st day of the first spaceflight of her career. The Spokane, Washington native is a colonel in the U.S. Army with a degree in astronautical engineering from West Point and a couple of master's degrees on top of that. But that's not all there is to know about her. There are things like her unusual birthday request in the 6th grade, and her favorite sport, and the fate that befell her favorite movie at the hands of her brother.
Okay, one thing that most people don't know about me is that I've wanted to be an astronaut since I was 3 years old. That's when I first told my mom that I wanted to be an astronaut. When I went off to preschool, I told her I was going to school to learn to be an astronaut. And when I was in kindergarten, I wrote my first very poorly written book on going to space on the Soyuz vehicle. When I was in 6th grade, I had a birthday party and I asked every single one of my friends for a calculator for my birthday. And I didn't tell my parents because I was too embarrassed, but I got a lot of calculators and I was super nerdy about it. But one of the things that I learned was, you just got to be yourself. I wanted a bunch of calculators. I got a bunch of calculators, and that was okay. I was a huge nerd then, and I'm still a total nerd now, but hey, nerds get to go to space. Another thing most people don't know about me is that I played rugby. Well, maybe if you're close to me, you probably know that because I'm a little bit crazy about rugby. And the last time that I played was about a week before I got selected here at NASA. I played in the English Premiership in England, and then I went back and I played on the U.S. national team. One of the things that I learned about myself playing rugby that I apply every single day is when you think that you have given everything and you have nothing left to give physically and mentally, you have a reserve that you can dip into and you can just keep going. I was a helicopter pilot in the Army. I flew helicopters for about 10 years before I became a test pilot. And one of the things that I learned flying helicopters is that when something looks really risky from the outside, that people that are doing it on the inside, they're not professional risk takers, but they're probably professional risk mitigators. One summer, I watched the movie Top Gun so many times, probably 3 times a day for a matter of months, that my brother finally took the tape out of the VHS and broke it over his leg so I could never watch it again. I was absolutely devastated, and so maybe it's partly his fault that I have to go live that dream as a military pilot. But you never know where you're going to get inspiration from, and if you're inspired, well, then just keep doing it, even if your brother says not to.
While today's astronauts work on the International Space Station and train for upcoming missions, NASA is preparing its next class of astronauts to be ready for future spaceflight assignments. The members of the 2017 astronaut class completed their first year of astronaut candidate training at the Johnson Space Center in Houston last year. Here's a look at that next group of space travelers as they moved out of the classroom and into more hands-on training.
First 6 months, we were really getting our feet under us, just getting to know one another, really doing mostly classroom type training.
Next 6 months has really picked up the pace a lot, and we've covered so many different things, everything from learning to do spacewalks in the neutral buoyancy lab, a giant swimming pool.
The first dives were incredible. The team of people that work at the neutral buoyancy laboratory are amazing. They work really hard to make it as much like space as possible, like doing a real spacewalk.
Getting in the suit for the first time was just really surreal.
We get into the suit, you get pressurized. It's a really cool experience to finally get in that spacesuit for the first time.
Totally unreal. I remember being in the pool and looking at my hands, and they have actual spacesuit gloves on, and just thinking this couldn't possibly be real life.
We went to New Mexico to study geology, but first of all, we spent a week here at Johnson Space Center working with an incredible group of PhDs that taught us geology, very intense week-long class.
We went out to the upper gorge region of the Rio Grande del Norte, and For that, it was really cool because we went to a region that had a lot of volcanic activity, and we're basically trying to piece together the story of how that region formed.
We were broken up into teams, and we got to actually go out and map different structures in the field, pick up rocks, break them open with a hammer, and actually form our own hypotheses, and then set about trying to explore them. It was a really great experience.
KSC trip was incredible. Getting out there, and for me, the first time to get to go out and touch rockets was really incredible. We got to see capsules, we got to see CST-100, we got to see SpaceX.
For me, I had never been there before. This is, the site where we've launched so many incredibly important missions through NASA's history.
I had been there back in 2006 for a shuttle launch, and to be back almost 12 years later as we're getting ready for a commercial crew to launch from Cape Canaveral again, you could sense the excitement building in anticipation for that. So that was really cool to see.
And it was really exciting for me to see just how alive it really is today, all of the different vehicles that are being built and being launched right there at Kennedy.
The land survival trip, we went to Maine for that, where the military does their survival training as well.
And that entailed a lot of learning things like land navigation, how to build shelters, but it was also especially important for team building and group dynamics. It was a great way to bond with the whole group. A few of us have also gotten a chance to work at Ellington Field doing field maintenance, it's called. So using the T-38 as a way to train on mechanical tools, doing repairs, learning things like sheet metal work, and just generally getting to know also some of the mechanics at Ellington Field.
And on Friday, I have my first, what we would call an integrated mastery. So it's going to be me in the mock-ups behind us with a group of 20 to 30 instructors as I go through my first exam, first major exam for the International Space Station.
Across the board, one of my favorite parts of this job has been getting to know my other classmates. Everyone is so collaborative, really working together to lift each other up and building on each other's strong points.
This group has been incredibly close, and every single one of us adds a lot of value to the team, and I think that's been one of the best parts of being here and training here.
So, want to get another look at any of the stories we featured today? And who wouldn't? Check us out on YouTube and Facebook, and there are the addresses right there in the handy blue box. And while you're at both of those spots, look around. There's a lot of other cool stuff you'll find about NASA and America's human spaceflight program. I also want to remind you that while you're out in the internet, check out Houston We Have a Podcast. This is folks here at NASA talking about their work in all aspects of space exploration. The new episodes post on Friday. Today, we are up with a second of a two-part series that we started back in December about the historic Apollo 8 mission, the one that first put people in orbit around the moon in late 1968. Go to nasa.gov/podcasts. You'll find today's episode and all the previous episodes. You'll also find the full catalog of all of the different NASA podcasts, all in the same place, nasa.gov/podcasts. You can also listen to any of them on Apple Podcasts, Google Podcasts, and SoundCloud. This is Mission Control Houston.